Hello, I'm Dave Baring, Technical Director here at TriStar, and welcome to another Tech Talk. Today we're going to be covering another of the quadrant materials, specifically the Techtron product. Now there are two materials in the Techtron family from Quadrant. They are both based on the PPS resin system, which is polyphenylene sulfide. And the two materials we're going to be talking about today are the straight Techtron, which is the unfilled material, and Techtron HPV, which is a very, very good and very unique bearing grade material. Now, Techtron, or PPS in general, is an interesting material. It's what we would consider to be kind of a tweener material. Which means that it's a material that has the physical properties of other high-performance materials, but from a price standpoint, you're really closer to engineering plastics like your nylons and your acetyls and your polyester materials. So it kind of fits right in between in terms of cost effectiveness, but it has many of the very strong properties of high-performance materials. Around TriStar, we like to refer to it as poor man's peak, because as you see as we go through some of the information here, it has many of the same properties as peak, but with a slightly lower temperature range, and that's really the only trade-off that we see. So let's take a look again at our infamous triangle, and you can see here that the PPS product, the Techtron product, is right up in the high-performance materials, right along with PEEK and polyether imides and some of the materials that you are aware of that meet 400-plus degree operating temperatures. But as we look at some of the main characteristics, you'll see that a lot of these are very similar to PEEK. First of all, the continuous operating temperature of the Techtron is 425 degrees F. That's obviously a number considerably higher than the engineering plastics, which are typically in the 180 to 220 degree range. So you've got a couple hundred extra degrees of operating temperature. It's about 60 or 70 degrees below peak. So that's why we say it's one of those tweener materials. It just fits right there in the middle in terms of temperature function. In terms of its physical strength, it's got excellent retention, as do all the high-performance materials. So mechanical strength, creep resistance, stiffness, all of these features that you expect in a high-performance material are maintained across its operating temperatures, and so you don't see a significant drop-off until you get up to or close to its deflection temperatures. Moisture absorption is virtually zero with this material. In fact, we'll see a chart here in a few minutes that shows that it's the closest to zero as you can get in any of the thermoplastic materials. Because of its dimensional stability, this material can be machined to very tight tolerances, and it's a fairly easy material to machine. If you pay attention, so you can get really nice parts, good clean parts, but most importantly, parts that have good dimensional stability. The Techtron materials do very well in gamma radiation and other sterilization techniques, so it is a material that is used quite frequently in FDA applications where you might be exposing it to gamma radiation. Chemical resistance is very, very similar to PEEK. There are very few things that affect it very critically, and so it's a very strong material in terms of its chemical exposures, and can be used in a lot of chemical components and in the whole, almost the whole spectrum of the pH range. Low flammability, that's kind of an inherent factor with the Techtron and the Techtron HPV. Now, talking about the moisture absorption, you can see here on this chart that PTFE, which is usually listed as nil, But the Techtron material and PPS in general is right there close. It's less than PEEK, it's less than Ultum, and it's obviously very, very much lower than the imidized material like Torlon. Now let's talk first about the straight Techtron material. Even though that's the trade name, Techtron is also the unfilled version of this family. Most of the PPS that you see on the market is usually going to have some kind of a filler. There's a lot of the Riton product out there, or Fortron, where glass fibers, carbon fibers, and other fillers are used, and that's primarily because of a historically difficult material to process in some ways. But the Techtron material, being a virgin material, allows for a lot of interesting applications, and one of those is that it is FDA compliant. If you have glass and carbon fillers in it, you won't have that compliancy. So that's kind of a key point here to keep in mind, that it is a very effective material when it comes to some medical instrument and biological applications. Again, as I mentioned before, the retention mechanical strength, it's a very good candidate if you're looking at structural components in place of PEEK, and certainly in place of the softer materials like fill Teflons. A lot of applications where you can use Techtron to replace metal, like stainless steel or steel, because of that very strong mechanical potential. Again, zero moisture absorption, steam service is not a problem, so autoclaving is not an issue. The tight tolerances, as I mentioned before. And then, so again, this being that infamous tweener material, and also a poor man's PEEK, if your temperature is at 425, this is a very, very good straight across replacement in most properties to PEEK. Now the Techtron HPV, which is the bearing grade version, is unique in terms of its makeup. There are other bearing grade PPSs out there, but the HPV material from Quadrant is unique in how it's made in terms of its fillers. Again, we get the same mechanical properties, all of the very strong mechanical properties, and so for a bearing application, again, with the temperature being the driving force here, it's a very good material to replace bearing grade PEEKs if the conditions warrant. The zero moisture absorption, steam service holds true for the HPV. You can hold tight tolerances on it. The chemical resistance, again, comes into play. It's not affected by solvents under 392 degrees Fahrenheit. So again, we can use this in a lot of chemical applications in terms of pumps and valves and things like that. The HPV is also FDA compliant, even though it's not white, it's blue. The straight Techtron is white, but the HPV is a very distinguishable color of blue. Again, under 425 degrees, it's a great replacement for bearing grade PEEK. Now, one of the other areas that we've had a lot of success with this HPV material is in the food processing industry. It's a very, very strong candidate because it's unaffected by the CIP solutions that are being used now. So, for either bearing applications or structural applications in the food industry, again, a very, very strong candidate. And then low friction and wear properties compared to a lot of the other polymers, especially, again, if you're looking at comparing it with PEEK or even PTFE in some cases. This next chart shows the relative wear. When we talk about wear factor with plastics, we're talking about their K factor. And so you can see here that the Techtron HPV has a K factor of 62, which is less than the acetyl materials. It's less than the PEEK HPV, which is the bearing grade PEEK. And obviously it's a much better material over an unfilled PPS or an unfilled peak. So as you can see, though, the wear factor is very, very low on this material relative to other materials. The other key factor is limiting PV. We want to know what the PV ratings are of any material that we're using as a bearing when it comes to plastic bearings. And so as we take a look at some of the same materials here, the acetyls have a fairly low PV, 2700. And again, if you remember previous discussions that we've had, PV stands for pressure times velocity, and it is a number, a rating number that is given to every polymer and every plain bearing material for that matter. And it's an important factor when we're trying to determine whether a material will stand up to loads and speeds of any given application. So obviously the lower the number, the lower potential it is in terms of its bearing capabilities. But you can see here that Techtron HPV is rated at 8750. The Techtron, just because of its inherent capabilities in terms of higher PVs, is up to 20,000, and these numbers are with a four times safety factor. So if you consider that, the HPV material, the Techtron HPV material, very, very good bearing material for a lot of the mid-range load and speed applications. Now this is another summary chart that gives you an idea of where the Techtron HPV falls into with other materials. You can see here we've got kind of a recap, the PV of the Techtron HPV being 8750, K factor being 62. You can see the workable pH range of the Techtron is even better than the peak. The dimensional stability of the Techtron HPV, 3.3 versus the unfilled materials. And then finally the moisture absorption. So this quick look of the properties gives you a nice little overview of where the Techtron HP falls into play with other plastic materials. But the bottom line is that the Techtron HPV, again, we consider it to be a very, very good alternative in both structural applications and bearing applications to peak materials, especially if you've got operating temperatures in the 425, especially in the 300 to 425 range. There's really no real adequate materials other than Techtron and Techtron HPV for those types of applications. So it's it just fits a very interesting niche for us, especially when we're designing bearings. A couple of applications just to talk about real quickly. One of them for the HPV is as a vane material. This is a rotary pump, and in the past the customer has used thermosets like phenolics, cotton phenolics, things like that. And in this particular application, where there was a lot of different exposures in terms of chemical attacks and just unpredictable wear, the customer decided to make the change to the HPV because of the factors we talked about: dimensional stability, low moisture absorption, great PV numbers on it, low coefficient of friction, and just a number of different reasons to make that change. The thermoset materials, as you can imagine, are pretty brittle. And as they age, they get even more brittle and begin to crack and fail. So this Techtron HPV was a good replacement application for this particular design. And the next one we'll take a look at, this is a little bit unusual. This is an application where a customer has developed a microwave system for actually mixing, if you will, different materials, different fluid materials, and using microwave energy to cause that mixture to accelerate. And in this particular case, because of the different chemicals involved, because of the release properties required, they use a PTFE liner, but they needed something stiffer to function as a cup to hold that PTFE liner. So We use the Techtron HPV to give them that stiffness, to give them a good elevated temperature material inside the microwave, to give them good chemical resistance for the potential of splash over or something else that might occur from the liquids being tested, being microwaved. And then more importantly is that Techtron is microwave transparent. So they're able to get full energy of the microwave through the holder as well as the PTFE liner, and successfully get that liquid to do what it's supposed to do. A few other applications that we'll just finish up with, and again, the places we're going to use the Techtron and Techtron HPV is going to be in the replacement of PEEK or PTFE when you look at other polymers. But it can also be used to replace other metals. If some of the engineering polymers are right on the edge in terms of temperature, this is a good next step, again, because it is cost competitive, even though it takes a much higher temperature. And some examples of applications would be things like pump lantern rings, flow meter rotors, bearings for food processing equipment, as we mentioned before. CMP rings. This is something in the semiconductor market, and because of its dimensional stability, that's one of the reasons they looked at the Techtron for that application. Chip nests and sockets. We have a few accounts that specifically want the Techtron because for their nest and socket applications, they want the dimensional stability, but they want an unfilled material. And so the Techtron has worked very, very well in those applications. And then the dielectric values of the Techtron are very good too, so it makes a very good electrical insulator. So that's a quick overview of the Techtron and the Techtron HPV. Again, excellent materials from the Quadrant organization, and it's available in rod and sheet and tubular bar. And so if you think this might be a good candidate for your application, give us a call. We'll be happy to walk you through the application, be sure that this is the right call. And as I keep saying, this is a great tweener material. It really fits a niche where a lot of polymers miss the boat or are just too costly. So consider the Techtron HPV the next time you're in that no man's zone as far as temperatures go. We appreciate you joining us again for another Tech Talk, and go to our website if you have any other questions about the Techtron. The data sheets are on there, or you can just drop us a line through the Ask the Expert. Check our blog site every now and then. We occasionally will have information on applications, specifically on the Techtron and the Techtron HPV. So hope this has been of value to you, and thanks again for joining us.